I designed this problem to teach you how to use your calculator efficiently in AP chemistry. I've set it up here so that it says that you should use sequential calculations so you don't have to re-enter answers as you go along, because otherwise you have rounding errors which will hurt you on WebAssign, or more likely you'll make an error retyping in a number. We don't want to make those clerical errors. So the question says for you to perform this calculation without clearing your calculator or entering these intermediate answers, and also to use your algebra skills to determine the unit resulting from this calculation. Let's do the last part where we get the unit resulting from this calculation, because it's going to show us what we're after. I mean, this isn't just a bunch of numbers. We're going to find something out in terms of chemicals and understanding. And the unit's going to help us with that. So we've got them written down. Here's a unit that you'll be seeing in the future, atmospheres of pressure. You may have heard about that. That's pressure involving gases. Here we've got liters, certainly a unit you should know. Our temperature, average kinetic energy unit, Kelvin. And here we've got sort of a mixed unit. This is a constant that uses atmospheres, liters, moles, and Kelvin. And when you use a constant, you really should include the unit of the constant, not just the number. Otherwise, you're going to get some errors. And you'll see that especially with the gas law. So we're going to figure out the unit first. Let's see if anything cancels. Well, we have atmospheres and liters here in the numerator, and atmospheres and liters in the denominator. So that gets rid of a couple of these units. We're not going to have an answer that has atmospheres or liters in it. We've eliminated two of the units. Here we've got a ratio of per mole Kelvin multiplying kelvins, so the kelvins are going to cancel, and that just leaves us one unit. But that unit is in the denominator of a denominator. That's fun to say. As a result, this mole will become our numerator, and our answer will be our amount of material, moles. As I said, this is something that's going to explain to us some chemical principles. We've got a gas at a pressure and a temperature, and we're going to find out how much gas is really in there in terms of moles. As I say, you'll learn more about this later, but let me just jump ahead in terms of this thought process, and we're going to look at the equation sheet that you'll get with the AP exam. And here's the section where we're dealing with gases. And you can see here we've got 273 kelvins and 1 atmosphere. Now that problem had 273 and about 1. And down here we've got moles. And it says that there are 22.4 liters per mole, per 1 mole. So about 22 liters underneath these conditions, the ones that we have, are a mole. But we've got 1 atmosphere, we've got 273, but we only have 3.7, not 22. As a result, we know we're going to have less than 1 mole. In fact, probably a little bit more than 1/10. So, as I say, you have to really think about chemistry. You know you're going to use a calculator, but don't go brain dead when you use a calculator. It only is going to do the multiplication and division for you. You've got to do the understanding, and if you use that understanding, you can predict an answer ahead of time and also prevent yourself from making clerical errors. So now that I know my answer is going to be about 1/10 of a mole, an amount of gas, let's do the calculation. It's time to pull our calculator out to make it do its magic. And the magic is just multiplying and dividing, doing the number calculations that you put in. Well, let's start off. We'll put 1.07. Okay, double check your numbers. It's a pity when you do a problem in AP chemistry, and if you mix the number up, you're going to spend that time and have the answer incorrect, so that's wrong. But of course, let's multiply it by times 3.73. Nothing special about the calculator yet. Do your answers sequentially. I'm going to put an enter in here. I'm going to find out what that answer is. That sort of makes sense. I'm looking 1 times about 3.7 is going to give me about 4. Check your answers for reasonableness. So we've got about 4, and now we've got a division process. We're going to do 0.0821. We're going to be dividing it by about 1/10, So we're going to get a larger number. We've got about 48. And now this is where an error occurs very often for a lot of students. You see this calculation that you've set up, that you've written out to show your answers on an FRQ or when you're doing a multiple choice question. And you see times 273. But as I say, don't go brain dead when you're using a calculator. You've got to think. You've got to guide it correctly. It's a great servant, but you've got to give the orders right. This 273 is a denominator. So we're going to be taking our answer, which is the result of 1 times 3.73 divided by 0.08, and dividing it by 273. So this multiplication times 273 is going to give you the wrong answer. And as I said, if you were thinking, realizing your answers should be about a little bit more than a tenth, when you do that multiplication by 273, you'll get an absurdly large number. So let's do our division. Divided by 273. That's our Kelvin temperature. And here we've got a reasonable number. We said it was going to be about more than a tenth, and this is about a tenth. So you could write that number down, but this would be an embarrassment. The number that's shown here is the best that this calculator can do. It doesn't know about rounding, and that this is an impossible number to do in terms of measuring something. I mean, here you got 1, 2, 3, 4, 5, 6, 7, 8, 9 significant digits. I'm not sure a mole amount has ever been measured to that many significant digits. If you put this down, there's only 1 point that's removed on an AP exam for significant digits, but you don't want to lose that point. I mean, 1 point's the difference between a 4 and a 5. Don't embarrass yourself or me. I mean, when you put down what they refer to as a screen dump, the graders just cringe. And so here's our answer. And it makes sense. If you put down 1.781 or an extra sig dig or two, that's okay. They're not going to be that worried about you. But if you put out an entire value like this, arg, please, 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 please don't do that. Now, you could have done this in one calculation. You could have done 0.017 times 3.73 divided by 0.0821. And again, don't forget, divided by 273. You'll get that same answer. But I advise doing it in a series of steps. Now notice they carried the answer over. You didn't have to write in 3.991 and then do 3.9911 divided by, you're going to copy numbers wrong. So use this sequence, and actually when you're doing an FRQ, you want to show your intermediate answers because you may be able to get some partial credit. One other little trick, but I don't advise doing it, is when you've got a pure multiplication division like this, you don't even have to follow the order. You can do 1.07 divided by 0.0821. Divide by the denominator and multiply the numerator. So I'll put a times 3.73, and then I'll finally divide by 273 and get that same answer. But I don't recommend that. Now, use the sequential method where you use a previous answer so you get the intermediates so you can see what's going along. Think while you're doing this, saying, okay, we're finding moles, we've got some gas law. And you'll find out more about moles and gas laws in the future by the end of the semester. All right, use your calculator wisely.